Hello everyone, I'm Namita Aini, studying in Stephen Pittsburgh College of Engineering. Today we will discuss about compiler design and its phases. First, compiler design. Compiler design involves the creation of a compiler, which is a specialized program that translates high-level source code within a programmable language into a lower-level target language, often machine code or intermediate code. The compilation process typically involves several distinct phases. Here are the common phases of the compiler: lexical analysis, syntax analysis, semantic analysis, intermediate code generation, code optimization, code generation, code linking and assembly, error handling. First, we'll discuss about lexical analysis, also called as scanner. Purpose of lexical analysis is to break the source code into a sequence of tokens, components. Lexical analyzer scans the source code and converts into a stream of tokens based on regular expressions. Regular expressions are the pattern that define the structure of tokens. Finite automata models the token recognition process. Output of lexical analysis is stream of tokens represent the basic building blocks of the source code. Next, syntax analysis. Purpose of syntax analysis is to check whether the sequence of tokens conform to the grammatical structure of the programming language. Components. Syntax analysis uses a formal grammar to be context-free to analyze the syntactic structure of the code. Context-free grammars are describes the syntactic rules of the language. Farsi trees. Hierarchical structure representing the syntactic structure of the source code. Output of syntax analysis is abstract syntax tree that captures the hierarchical structure of the program. Semantic analysis. Purpose of semantic analysis is to ensure the program has a meaningful interpretation. Components are semantic analyzer, which checks for the synaptic errors such as type mismatch, undeclared variables, etc. Symbol table manages information about variables, functions, and other program entities. Output of synaptic analysis are symbol table and decorated AST, where AST is the argumented with synaptic information. Intermediate code generation. Purpose of intermediate code generation is to translate the source code into an intermediate representation. Components are intermediate code generator, produce an intermediate code that is independent of the source and target language. Output of intermediate code generation is intermediate code, a low-level representation of the source code. Code optimization. Purpose of code optimization is to enhance the intermediate code to improve the efficiency of the generated code. Components of code optimization are optimizer, applies various optimization techniques to reduce execution time or improve code size. Output of code generation is to optimized intermediate code. Next, code generation. Purpose of code generation is to translate the optimized intermediate code into a target machine code or another intermediate code. Components of code generation are code generator, generates target specific code based on the optimized intermediate code. Output of code generation is machine code or target intermediate code. Code linking and assembly. Purpose of code linking and assembly is to combine separately compiled modules into a single executable file. Components of code linking and assembly are linker. Linker resolves external reference and combines objects files into an executable, and loader loads the executable into memory for execution. Output of code linking in assembly is executable code. Error handling. Purpose of error handling is to detect and report error during various phases of the compilation process. Components. Error handler identifies and reports errors to the programmer. Output of the error handling is error messages and diagnosis to aid in debugging. Conclusion. In conclusion, compiler design is a crucial process in software development that facilitates the translation of high-level programming language information code or intermediate code. The design of compiler involves several distinct phases, each serving a specific purpose and contributing to the overall efficiency and correctness of the compilation process. These phases work together to produce an executable program that is faithful to the original source code. The compiler not only translates the code but also perform optimization to improve runtime performance. Compiler design is to balance between producing efficient machine code and providing meaningful error messages to aid programmers in debugging. Successful execution of each phase contributes to the creation of the reliable, optimized, and error-free software. Thank you.